So let us try to understand an entire design flow. Okay, in this section, we'll not be going into much detail right now, and some of the strategies which could be very helpful to handle certain situations, such as if you want to perform an area optimization or the resource optimization or the timing optimization. Okay, and what type of component you want to invoke in an HDL, that will be understanding in the next section, right? So this two section will be entirely designing with the flow. Okay, understanding the fundamental steps that we have in a flow. So let us start blindly with an example, and then I will just be going through an entire step, right from creating a source to downloading a program on an FPGA, right? And then we'll be going into detail of each step that we perform, right? So when you double click on an Vivado, you get this ID. Okay, so we'll start with create project. Now in fact you'll be finding there are various options over here. Okay, so if you have an existing project, we'll be utilizing open project. If you want to invoke an example project which are available in Vivado, you just need to select this option, right? And rest of the thing we'll be discussing as and when we require them, right? So we do not have any existing project being created, so we'll just be starting with a create project, right? This will automatically open up a new project wizard. We'll just be clicking next. Now here you get the option to specify the name of a project and the directory where you'll be storing all the project related information, right? So when we create a new project, there are multiple directories which are created, okay, storing a different thing related to a process. For example, we have a multiple step, such as we have a simulation sources, we have a constraint, we have a design source, we have a synthesis and implementation. So each of the files which are generated in this process are stored into different directory, right? So all of this directory will be created in the location where you specify, right? So you could clearly see that when you specify a location, automatically the name that you create will be the directory where you'll be finding all the file related to that project, right? So you could choose a single location where you will be storing all the project related to this course, and then will can give a name depending on the project that you are implementing, right? So right now I'll be sticking to the default project location as well as default project name, right? We'll just be clicking next. Now here you see a different project type, right? So as we progress further in the next video, we'll be understanding what each of this means, right? So blindly choose an RTL project, click next. Now you get a window where you could specify the source, right? So remember, these are some of the mandatory options. So type of language that we are utilizing here for developing a source is VHDL. So see that you choose this as VHDL. Simulator language must be mixed. Okay, and then you get an option. So if you have an existing source file, you could just specify an add file. If you have a multiple source file, you could just specify a directory. And if you do not have any existing source file, we could just click on create file, right? So that is what we're gonna do. Create file. We could give a name to the source file, right? So let us try to implement the AND gate. Okay, so we'll just be naming this as AND underscore. Again, the name that you provide to the source code, okay, will be a name your entity will have, right? So this should follow the typical rule, that is you are allowed to use only the alphabets, okay, at the start, and then you could utilize the numbers, right? And the special character that is allowed is only the underscore, right? So something, if you try to mention like this, so this is not allowed. You cannot simply start with a number. You need to start with the alphabet, and then underscore is the special character which is allowed, and then you could add a number, right? So these are some of the mandatory rules that you need to remember. So we start with an AND gate because that is what we're going to implement. Underscore, the number of output pin that our AND gate will have is 1, and the number of input pin that our AND gate have is 2, right? So this will be the terminology that we follow, okay, when we will be working with the different systems, right? So we'll just hit OK, and now you could see that here we able to add our source file, and the extension that we get is .vhd, right? And this source file will be used for both synthesis as well as simulation. So if you are writing the test bench code, you could just go ahead and click over here, and you could specify that we want to perform a simulation only, right? But here the same source code will be used for both synthesis as well as simulation. We'll just be going ahead and click next, right? So constraint we will be adding later on, so we'll be keeping this empty. Click next, and then you get an option where you could select the board that you are utilizing, right? So the board that I'm using over here is Sync Z710, so I'll just be selecting Zybo Z710. You could specify any of a board that you are utilizing and then click next, right? So this is the project summary. You have added one source file, no constraint file is added, right? This makes sense, and the board related information, right? So once this is done, just click finish. Now remember, we have added the source file, right? So as soon as our directory is ready, you'll be simply getting a pop-out, right? So you could see we are now getting a pop-out to define a module, right? So where you need to mention the input and output. Now you could ignore this, but if you specify, you will be getting a template, okay? And that is an easier way to start. So we'll just be adding, for us, A and B, let us assume are an input of single bit size, right? So whenever we have a single bit size, we do not need to check this option, which is bus, right? If you want to specify a multi-bit bus, so you just click this, and let us assume you have 2-bit size, okay? Then you need to specify the MSB bit is 1 and LSB bit is 0. This is how you specify 2-bit, right? So bus is used to select the multi-bit bus for input and output, right? Now here you could see three directions are available. So we have an input, output, and for a buffer, you have an in out, right? For an output, we'll just be utilizing the name Y and the direction will be out, right? Once you do this, you just need to click OK. And once you specify input and output ports in the define module, okay, you'll be finding Vivado will automatically create a template for us, right?